So, exponential distribution has a special property, it is known as memoryless property. Exponential distribution usually model for the data where this is kind of a lifetime data. Suppose we buy some electronics goods from the market, and then we want to know what is the lifetime of the electronics goods. So, it may be 1 year, 2 year. Now, suppose the electronics goods that already it survived up to 2 years, and then we want to know what is the probability additional 1 year it will be working. So, then initially it may be some probability. So, suppose here suppose the electronics goods already it works up to 2 years. Now, we are asking the probability that what is the probability it will work more 1 year. This will be same as the probability that initially if we ask that it will work 1 year. So, that means if the random variable or this kind of random phenomena does not include does not actually memorize that already 2 years it works, it already worked. So, basically it is actually forgetting, because usually if some electronics good already working 2 years, that means we assume that the probability may be very less that it will work more 1 year at the when it was compared to the when it was new. But this kind of random variable has this property that it forgets forget that it already worked 2 years. So, this kind of property it is known as memoryless property. So, this memoryless property is explained in this way. So, exponential distribution has the memoryless property. If x has exponential lambda, and then probability that x greater than x plus a given x greater than a, it is same as probability that x greater than x for any real number a and x. So, that means probability that suppose any point if you take so suppose some real number, suppose a. So, probability that x greater than x plus a. So, that means we want some x here, any real number x, and here also some x here, the same amount. This is same as probability that x greater than x. So, whenever it is new that electronics goods was new, that it will survive probability that it will survive x time up to x time greater than x time, it is same as the probability that it was not new whenever it is already survived a, and then another x time it will be x years or some x hours or some units, it will survive more x year. This probability is same, it is known as memoryless property. So, let us see that whether this exponential distribution has this memoryless property. So, let us recall that whenever x has a exponential distribution with parameter lambda, then the probability density function it is given by e to the power of minus lambda x whenever x is greater than 0, less than infinity, 0 otherwise. From here you can derive the cumulative distribution function f x x. This is nothing but probability that x less than equal to x, which is nothing but it is 0 whenever x is less than 0, greater than minus infinity. We have already discussed this cumulative distribution function earlier. So, you can see that this is the cumulative distribution function 1 minus e to the power of minus lambda x, it is 1 minus e to the power of minus lambda x whenever x is greater than 0, less than infinity. So, now we want to find, suppose let us find the probability, this probability that x greater than x plus a, probability that x greater than x plus a given x greater than a. So, this probability we want to compute. So, this is nothing but, suppose this is a conditional probability, this is a given a x greater than x plus a intersection x greater than a by probability of x greater than a. So, now note that suppose it is a, it is b. So, probability of a given b is probability of a intersection b by probability of b. Now, probability that x greater than x plus a, it will be subset of this event, because whenever x is already greater than x plus a, if x greater than x plus a, that means it will be x greater than x a. So, this implies this. So, basically x greater than x plus a implies x greater than a. So, x greater than x plus a, this event actually subset of x greater than a. Hence, x greater than x plus a intersection x greater than a, because this is subset of this is nothing but x greater than x plus a, this event. So, that we are writing again. So, this is nothing but probability that x greater than x plus a by probability that x greater than a. Now, we want to find these two probabilities. So, here we will find that. So, what will be probability x greater than x plus a? Now, see that this probability we know. So, then probability of x greater than x plus a, it is nothing but 1 minus of complement of this x less than equal to x plus a. So, x less than equal to x plus a will be 1 minus f x of x plus a, because all are positive. So, we will use this formula. So, this is nothing but 1 minus of 1 minus e to the power of lambda x plus a. So, then this is cancelled. So, e to the power of minus lambda x plus a. Now, if you want to find what will be the probability that x greater than a. So, similarly we can find. So, it is nothing but 1 minus probability of x less than equal to a, which is nothing but 1 minus x less than equal to a is nothing but x x of a, which is 1 minus a is a positive number. So, this will use here 1 minus e to the power of lambda a. So, then it is a minus lambda a. So, that we will use here. So, this is nothing but e to the power of minus lambda x plus a by e to the power of minus lambda a. So, let us erase all these things. We have already computed this value and we will use this. So, it is e to the power of minus lambda a. Now, this is nothing but e to the power of minus lambda x into e to the power of minus lambda a by e to the power of minus lambda a. So, this is cancelled, it is nothing but e to the power of minus lambda x. So, what is e to the power of minus lambda x? This is how we can represent it. This is nothing but 1 minus of 1 minus e to the power of minus lambda x. So, this is nothing but 1 minus, this is f x x. So, this is probability. So, basically this is nothing but probability x less than equal to x. Here 1 minus lambda, it is probability which x is a positive number, x less than equal to x, which is nothing but 1 minus of x less than equal to x is nothing but probability that x greater than x. So, that is the relationship we got. So, that is here you can see that probability x greater than. So, then exponential distribution has this memoryless property. So, that is why we found that probability that x plus a, not x plus a, x greater than x plus a, x and a are positive number, and then given x already survived, then this is nothing but x greater than x. So, what that we found. So, that is why it is called a exponential distribution has a memoryless property. So, let us discuss some numerical example. So, here suppose that during rainy season on a tropical island, the length of the shower has an exponential distribution with parameter lambda equal to 2, time being measured in minutes here. So, exponential distribution parameter it is given lambda equal to 2. What is the probability that shower will last more than 3 minutes? So, here it is given that x has exponential distribution, it is the shower time, it will last, where lambda is equal to 2, parameter lambda is lambda equal to 2, distribution with parameter lambda equal to 2. Now, what is the probability? So, then we know already the what is the probability density function now, because lambda is equal to 2, the probability density function of x is given by f of x x. This is nothing but lambda e to the power of minus lambda x, x is greater than 0 less than infinity, 0 otherwise. So, here lambda is equal to 2. So, we can replace that value also. So, this is nothing but 2 e to the power of minus 2 x whenever 0 less than x less than infinity 0 otherwise. Now, what is the probability that shower will last more than 3 minutes? So, we want to find here shower, this is this time. So, more than 3 minutes we have to find probability that x greater than 3. So, probability x greater than 3 is nothing but either you can use the, this is 3 to infinity f of x dx, this is the definition, or you can take complement, then you can use the distribution function. If you use directly this formula, then this is nothing but integration 3 to infinity 2 e to the power of minus 2x dx, which is nothing but 2 e to the power of minus 2x by minus 2 3 to infinity. So, this is nothing but it is minus of this at x goes to infinity, this is 0, and then minus of then e to the power of minus 3 2 into we put x 3. So, e to the power of e to the power of minus 6 3 2 into 3 6. So, this is the probability that probability x greater than 3. This is the probability what is the probability that a shower will last more than 3 minutes. If a shower has already lasted for 2 minutes, what is the probability that it will last at least 1 more minutes? So, here it is asked that already it is last it has shower has already lasted 2 minutes. So, here A is equal to 2. So, that means already shower lasted 2 minutes. So, 1 2. So, now question is that what is the probability that it will be at least more than 1 minute. So, that means probability that it will last for at least 1 more minutes. So, that means this is x greater than 2 plus 1. So, it is this probability it is asked that x greater than a already it is already a plus 1, given that x is already 2 a greater than a. So, by memoryless property we know that this is same as probability that. So, for any because it has a memoryless property, consider a is equal to 2, x is equal to 1. So, this is nothing but probability x greater than a plus x given x greater than a, this same as probability x greater than x. So, that is why, so it does not depend upon a here. So, just you put x greater than x is 1. So, this is nothing but, so hence probability that x greater than 2 plus 1 given x greater than 1, this is nothing but probability x greater than 1. So, x greater than 1 we can find using distribution function also, like this is nothing but complement of 1 minus probability of x less than equal to 1. So, what is the distribution function CDF? So, CDF can be written as fxx, this is nothing but 0 whenever x is less than 0 greater than minus infinity, whenever x is greater than equal to 0, then 1 minus e to the power of minus lambda x, here lambda is equal to 2 it is given. So, we will write it 1 minus 2x whenever x is greater than equal to 0 less than infinity. So, this is nothing but f of x 1. So, this is nothing but 1 minus fx of 1. So, fx of 1 is nothing but if you put x is greater than 0. So, 1 minus of e to the power of 2 into 1. So, this is nothing but e to the power of minus 2. So, this is e to the power of minus 2. So, this is the answer. So, this is one example we discussed for the exponential distribution. So, hope you have understood the properties of the exponential distribution, and we have discussed some gamma function also. So, that will be useful now because we will now discuss gamma distribution. So, this is another important continuous random variable that is very much widely used. We have to learn it, and also some of the properties we will learn. So, gamma distribution, it is a continuous random variable x. A continuous random variable x is said to have a gamma distribution with parameter alpha greater than 0, lambda greater than 0, denoted as x as gamma alpha lambda, if its probability density function is given by this. So, x to the power alpha minus 1 e to the power of lambda x, lambda to the power alpha by gamma alpha with this range, where gamma alpha you know that already discussed that gamma alpha is the gamma function. So, some different variation of this form is there, but we will follow mostly this form, standard form. this variation of above form can be found by reparametrization of k is equal to alpha and theta equal to 1 by lambda. So, there are different variation, some of the curve for different values of k and theta for the gamma density curve it is given, and the cumulative distribution function also you can see here it is given. So, let us discuss some of the important properties of gamma distribution. So, what is gamma distribution? A random variable x is said to follow gamma distribution with parameter. So, what are the parameter? It is alpha and lambda, parameter alpha greater than 0 and lambda greater than 0. There are two parameters of a gamma distribution and all are real number, but it has to be positive real number. If the probability density function this is PDF of x is given by, so f of x this is nothing but, so how it looks like, because it is parameter alpha and lambda. So, x to the power alpha minus 1 e to the power of minus lambda x, then lambda to the power alpha by gamma alpha. Let us see that. So, see that lambda to the power alpha e to the power of minus lambda x to the power alpha minus 1 by gamma alpha, whenever x is greater than 0 less than infinity, already range of alpha and lambda it is given 0 otherwise. So, this is the probability density function. So, now we want to see that whether it is following all the properties of a density function. So, that see that it is always greater than equal to 0, no problem, only you have to check that whether it is this integration f of x dx, this should be is equal to 1. Now, if you do this integration, now see that this density function is non-zero in the interval 0 to infinity. So, this is nothing but 0 to infinity lambda to the power alpha x to the power alpha minus 1 e to the power of minus lambda x by gamma alpha dx. Now, how we can find it is how to do this integration? We will use our gamma formula, that gamma function we have already discussed earlier, if you can remember. So, you can go through again, this is the gamma function. So, gamma alpha is defined by 0 to infinity x to the power alpha minus 1 e to the power of minus x dx. Not only that, all these properties also we will use here. So, here we will see that. So, now suppose if you want to do this integration, now what we will do first, because what is gamma alpha? Gamma alpha formula here I will keep this gamma alpha. So, gamma alpha is nothing but 0 to infinity e to the power of x to the power alpha minus 1 e to the power of minus x dx. Now, if you want to, so with this gamma function, so here e to the power of lambda x is here, but x to the power alpha minus is okay, this is a constant. So, e to the power of lambda x it should be looks like e to the power of minus x. So, we will take a transformation. So, what transformation we will take? So, lambda x we will take the transformation z, where x is equal to z by lambda. Now, dx will be dz by lambda. Now, whenever x goes to 0, z goes to 0. So, this is nothing but we will take this constant outside, lambda alpha by gamma alpha. Now, whenever x goes to 0, z goes to also 0, x goes to infinity, z goes to infinity. Now, x to the power alpha minus 1. So, x is nothing but z by lambda whole to the power alpha minus 1 e to the power of minus z, lambda is equal to z, and then dx is nothing but dz by lambda, So, then this lambda you can see that lambda to the power alpha by gamma alpha. Now, here also lambda to the power alpha minus 1, from here we will get lambda. So, that is why it is lambda to the power alpha. So, that is why it will cancel with this, and then the remaining thing will be this is 0 to infinity z to the power alpha minus 1 e to the power of minus z dz. Now, you can compare with this formula. Here this integration x to the power alpha minus 1 e to the power of minus x dx 0 to infinity. Here z to the power alpha minus 1 e to the power of minus z dz 0 to infinity. So, this is also same as the gamma alpha. So, that is why this is nothing but gamma alpha by gamma alpha, this is equal to 1. So, it is a probability density function. Now, we will discuss the some of the important characteristics. So, one of the important characteristics is are the moments. So, first order moments we will compute. So, what is mu 1 dash? So, mu 1 dash is nothing but expected values of x. So, then expected values of x is defined by minus infinity to plus infinity x f x x dx. So, now this is nothing but because it is non-zero when it is in the positive, whenever it is non-zero, whenever x equal to 0 to infinity, otherwise it is 0. So, then this is x, f x x is nothing but what is the formula, lambda to the power alpha x to the power alpha minus 1 e to the power of minus lambda x by gamma alpha dx. Okay. So, how we can find it? So, now we require, you can remember that suppose you want to find variance, then you require mu 2 dash also. So, here we will generally we will find out what is the mu r dash. So, mu r dash is nothing but for r is equal to 1 to like this x to the power r. So, this is nothing but x to the power r. So, this is nothing but x to the power r for r is equal to 1 to any integer value x to the power r. So, that it will be helpful because if you can find a if we can simplify it, so then it will be useful. Whenever r is equal to 1 we can find mu 1 dash, whenever r equal to 2 we can find mu 2 dash like this. So, then we just simplify these things. So, because lambda to the power alpha by gamma alpha, this is a constant. So, this will be nothing but 0 to infinity, it is outside the integration x to the power alpha alpha minus 1. So, it will be x to the power r plus alpha minus 1 e to the power of minus lambda x gamma alpha already outside the interval, this is dx. So, then we want to write this function in a form of a gamma function. So, gamma function we know that gamma alpha is nothing but 0 to infinity e to the x to the power alpha minus 1 e to the power of minus x dx. So, this e to the power of minus x here e to the power of minus lambda x, we will take this transformation again, same transformation we are doing, lambda x is equal to z. So, that x will be nothing but z by lambda and dx is nothing but dz by lambda. So, this limit will not change. So, then what we will find, this is lambda to the power alpha by gamma alpha, and then this is limit does not change, x goes to 0, z goes to 0, x goes to infinity, then z goes to infinity, and x to the power r plus. So, x is nothing but here z by lambda whole to the power r plus alpha minus 1, then e to the power of minus z, and then this is z by lambda. So, then this is nothing but lambda to the power alpha by gamma alpha. Note that this lambda here lambda to the power r plus alpha minus 1 into this is lambda. So, lambda another. So, it is nothing but lambda to the power r plus alpha. So, then it will be 0 to infinity z to the power r plus alpha minus 1 e to the power of minus z dz. So, now you compare these things with this. So, it is x to the power alpha minus 1 e to the power of minus x dx 0 to infinity, it is 0 to infinity z to the power alpha plus r minus 1 e to the power of minus z dz. So, it is nothing but gamma alpha plus r. So, then if you simplify these things, so this is nothing but lambda to the power, it is actually nothing but coming as a 1 by gamma alpha, and then this is this part will be gamma alpha plus r, because it is gamma alpha plus r minus 1 form, you can see here gamma alpha per 1. Here lambda will be lambda per alpha r plus alpha minus 1 plus 1 and then minus alpha. So, then this is cancelled, lambda to the power r. So, this is nothing but gamma alpha plus r by gamma alpha into lambda to the power r for different values of r. Now, we will put, so what we found that mu r dash, which is nothing but expected values of x to the power r, it is coming as gamma alpha plus r by gamma alpha and then lambda to the power r. It is coming like this, lambda to the power r, for r is equal to 1, 2, like this, any integer values, positive integer values. Now, if you put r is equal to 1, we will get mu 1 dash. This is nothing but gamma alpha plus 1 by gamma alpha by lambda. So, this alpha plus 1 we can write, we just discussed it, already discussed it. There is a formula, gamma alpha plus 1 is gamma alpha. So, so that we can simplify it like this. So, then gamma alpha cancelled, this is nothing but alpha by lambda. Now, for r is equal to 2, what will be mu 2 dash? Mu 2 dash will be gamma alpha plus 2 by gamma alpha. So, then this is nothing but also lambda to the power r is there. So, this will be nothing but lambda square. So, then we have to simplify, alpha plus 2 we can write alpha plus gamma alpha minus plus 1, and gamma alpha plus 1 we can write alpha gamma alpha. So, by gamma alpha by lambda square. So, then this will be coming like lambda to the power r is equal to 2, this is lambda square. So, this is gamma alpha cancelled. So, this is nothing but alpha into alpha plus 1 by lambda square. So, this is the mu 2 dash. Then we can simplify for variance also from here. What will be the variance of this gamma random variable? So, variance of x, this is nothing but mu 2 dash minus mu 1 dash whole square. So, mu 2 dash is nothing but alpha into alpha plus 1 by lambda square minus mu 1 dash whole square. Mu 1 dash is alpha by lambda whole square. So, we can simplify as much as possible. So, this is nothing but alpha into alpha plus 1 by lambda square minus alpha square by lambda square, which implies, which is equal to lambda square, then alpha into alpha plus 1 we can write alpha square plus alpha minus alpha square. So, this is cancelled. So, this is nothing but alpha by lambda square. So, variance of the gamma random variable is nothing but alpha by lambda square, and the mean of the gamma random variable is nothing but alpha by lambda.